What if your OSPF network was a ticking time bomb? Too many routers in one area can crash your network with overloaded routing tables and CPU meltdowns. In this video, I'll show you how OSPF areas act as firewalls to contain routing chaos, plus the golden rules for designing bulletproof OSPF hierarchies. Want to prevent network disasters? Let's dive in. OSPF area structure. A large OSPF network is often divided into several areas. Because if there are many routers that are part of the same OSPF area, then there could be several types of problems. For example, AA, larger routing table. This would cause high latencies on the router. You can also have problems with LSDB. This is because each router must keep an entry for each network in the same area, even if it is not in the routing table. And we can have a high consumption of CPU resources, because in a large network, there are many topology changes. And with each change, routers have to restart their SPF algorithms to update their routing tables. That's why the OSPF protocol allows routing to be divided into several areas. The main area is called backbone area. This is area 0, and all other areas must be connected to it. Multi-area, therefore, has several advantages. First, the size of the route tables is reduced because network addresses are abbreviated between areas. For example, on the topology, router R1 shortens routes from area 1 to area 0, and router 2 handles routes from area 2 to area 0. Both routers also propagate their own static routes by default. Then link status updates are less overloaded because there are far fewer routers exchanging LSA messages. And the last advantage is the reduced SPF calculations, because topology changes or any network crashes will only propagate within the area. For example, let's say that a link drops between one of the routers in area 2. Well, only routers in this area will exchange LSAs and return the SPF algorithm for this topology change. Router 1 will not receive LSAs that come from area 2 and will not recalculate its algorithm. Multi-area OSPF routing works on a two-layer area hierarchy. We have the backbone area, which can also be called the zero area or the backbone area. It is defined as the center to which all other areas are connected directly. And we have the areas, normal, which are not backbone. Here, their roles are to connect users and resources. Cisco recommends some guidelines for the optimal number of routers. An area should contain no more than 50 routers. A router should not be included in more than 3 areas. And it must not have more than 60 neighbors either. The last thing to see about OSPF areas is that there are 4 different types. We have internal routers. These are routers whose interfaces are all located in the same area. We have backbone routers, which are also called federator or area 0. These are the routers that are generally area 0. There are ABR routers. These are routers that have interfaces in different areas. And we have the ASBR type of router for Autonomous System Boundary Router. It is a router that has at least one interface associated with an external network. That is to say, to another autonomous system. For example, a non-OSPF network.